Good morning students. Up to the last lecture we have studied about the problem of current electricity. In that we see resistors in series connection. That problems we are already see. Okay. So in resistors are in series connection, there are we see formula is Rs is equal to R1 plus R2 plus up to Rn if n number of resistors are connected in series. Okay, so simply there we have to take addition of all resistors. Okay, so this is very simple formula to calculate the resistors in series. Now today we have to see resistors are in parallel connection. Okay, if you connect two or more resistors are in parallel connection, okay, at that time how the equivalent resistance of circuit we can calculate, that we have to see here. Okay, resistors in parallel connection. Now look at first problem is if resistors having resistances, okay, three resistors are given of 15 ohm, 20 ohm and 10 ohm. Okay, 15, 20 and 10 ohms are these three resistors are connected in parallel. Okay, which connection? Parallel connection. What is the effective resistance in the circuit? Okay, if these three resistances of 15 ohm, 20 ohm and 10 ohm are connected in parallel way, then what is the effective resistance of a circuit, that we have to calculate. Okay, so okay, this is the problem. Now we have to solve this problem. Okay, I already told you in previous lecture we have to solve this problem in steps. Okay, so first of all always we have to write given quantities. Okay, in every chapter, every problem I always tell the steps we have to follow. Okay, because we have mark for these steps. Given, always you get half mark. Okay, for formula you get half mark. If you put all the values properly, then you get half mark and your final answer will get half mark. So such a way marks of problems are divided, I already told you. So you have to write problem in that step. If you write your problem directly from here, then you will get only 1 mark. Okay, these two steps carry half mark, that also you have to remember. Okay, so first of all we have to write all the given terms here. Okay, so first is R1 is equal to 15 ohm, then R2, second resistor having value 10, 20 ohm and third resistor having value 10 ohm. Okay, so these three resistors are connected in parallel way. Now formula to calculate resistances in parallel, that we are also studied, that is the 1 by Rp is equal to 1 by R1 plus 1 by R2 plus 1 by R3. Okay, so such a way we can calculate parallel resistance, equivalent resistors when they are connected in parallel. 1 by Rp is equal to 1 by R1 plus 1 by R2 plus 1 by R3. So we know, now we know this formula. Now we have to put given values of resistors in this formula. Okay, 1 by R1, R1 having value 15 ohm, 1 by 15 plus R2 having value 20, 1 by 20 plus R3 10 ohm, so 1 by 10. Okay, so 1 by 15 plus 1 by 20 plus 1 by 10. So now we know we have to add these three quantities, but their denominator is not same, so we can't add these quantities directly. If we have to add these quantities, then first we have to make their denominator equal, common, then we can add all these three terms. But here we know denominator is not same, so we have to calculate is LCM, least common multiple of all these three terms, and there are 60 is the LCM of all these three terms. Okay, so look at here what the, if we have to make this denominator of all three terms are how much? 60, because our LCM is how much? 60. Okay, so 60 will be the common their denominator. So look at, to make this 60, what we have to do? We have to make this 15 multiplied by 4, then it will become 60, 20 multiplied by 3, then it will become 60, and 10 multiplied by 6, after that it will become 60. So for make denominator 60, we have to multiply 15 by 4, 20 by 3 and 10 by 6. So by same number we have to multiply to the numerator. Okay, so 15 by 4 is equal to 60. So 1 into 4 plus second term. If you have to make denominator 60 of this 20, then 20 into 3, same number we have to multiply to the numerator. So 1 into 3 plus how much? 10 into 6, 60. So 1 into 6 we have to take here. Okay, so 1 into 4, 4, 1 into 3, 3, 1 into 6, 6 divided by 60. Okay, so 60 is the LCM. We make common denominator, that is the LCM of that number is 60. According to that we have to multiply numerator also. Okay, so it will be 1 by Rp is equal to 13 by 60. Okay, this is the value of 1 by Rp. What? 1 by Rp. But we know when resistors are in parallel, then their equivalent resistor is nothing but the Rp. So that Rp will be become, what we have to take? We have to take reciprocal of this term. Okay, so Rp will be become 16 by 13. Okay, so we have to make reciprocal of this term. We have to take reciprocal of this term. So 1 by Rp will become Rp and 13 by 16 will become 16 by 30. Okay, so then their equivalent resistor will be 4.615 ohm. Okay, 4.615 ohm. Okay, so there are what happened? 3 resistors are connected, 15, 20 and 10. Okay, so look at here. If we see this problem for the series, okay, suppose one way we connect, this is series connection, these 3, then their equivalent resistance will be 15 plus 20 plus 10. So it will be equal to 45 ohm when they are connected in series. And now when these 3 resistors are connected in parallel, okay, Rp, that is the parallel, at that time equivalent resistance of this circuit is 4.6 ohms only. So look at the difference when resistors are connected in series and when they are connected in parallel. When resistors are connected in series, at that time their equivalent resistance increases, and when resistors are connected in parallel way, at that time resistance are decreases. Okay, so that is why whatever the household connections of electricity are always in the parallel connection. Okay, because resistance decreases. Okay, so that reasons also we have to remember. Now we have to see next topic like this. Now next topic, next problem we have to see, that is also similar to previous problem. Okay, look at here, we have to connect 3 resistances of 5 ohm, 10 ohm and 20 ohm in parallel connection. Okay, now we have to calculate now what is their equivalent resistance or effective resistance. So look at here again, same way we have to write all the given terms. Okay, so 5, 10, 20 are the 3 resistors are given here. Okay, then similar we have to write one formula of parallel resistance. Okay, so 1 by Rp is equal to 1 by R1 plus 1 by R2 plus 1 by R3. So we have to put the value of R1, R2 and R3 in this given formula. So R1 is 5 ohm, so 1 by 5 plus R2 is 10 ohm, so 1 by 10 plus R3 is 20 ohm, 1 by 20, 1 by R1 plus 1 by R2 plus 1 by R3, 1 by 5 plus 1 by 10 plus 1 by 20. Okay, now here we have to add again these 3 terms, 1 by 5 plus 1 by 10 plus 1 by 20. So again denominator is not same here. Okay, so again we have to find their LCM, least common multiple. We have to find that minimum small number which having in multiple of all 3 numbers. Look at 5, 10 and 20. So if you see 20 is the LCM of these 3 numbers, 5, 10 and 20. Look at 5 into 4, 20, 10 into 2, 20, 20 into 1, 20. Okay, so 20 is a multiple of all 3 numbers. Okay, so now we have to make common denominator 20 of all these three terms. Okay, look at first of all 5. So if we have to make this denominator 20, so we multiply by it 4. Okay, 5 into 4 20. We have to multiply two numerators same number also. So 1 into 4 plus this second term now 1 by 10. We have to make it a 20. If we have to make this denominator 20, then we have to multiply it by 2. This is the 10 into 2. Similarly, same number we have to multiply to denominator 1 into 2 plus. Now this three term 20. 20 into 1 is a 20. Okay. So 20 into 1, 1 into 1. Okay. So such a way that we have to make our denominator common. Okay. So look at here. What? 1 into 4, 4 plus. 1 into 2, 2 plus. 1 into 1, 1 plus. 5. 5 into 4, 20. 10 into 2, 20. 20 into 1, 20. So now denominator is common. So we can write here commonly 20. Okay. Such a way that we have to make denominator common here. Okay. And this is the important step in this problem. Okay. So unless this problem is very easy. Okay. So such a way we have to make first denominator common. So next step will be 4 plus 2 plus 1 divided by 20. So this 1 by Rp will be equal to 7 by 20. 4 into 2, 6 plus 1, 7. 7 by 20. Now we have to calculate this Rp. But this is the value of 1 by Rp. So Rp will be equal to reciprocal. Okay. So Rp will be go in the numerator. So this 20 will be go into the numerator. Okay. We have to change the numerator and denominator here. Okay. So Rp will be equal to 20 by 7 now. Okay. And we know 20 by 7 is how much? 2.85 ohms. Okay. Look at, if these three resistors 5, 10 and 20 are connected in parallel way, then their equivalent resistance will be 2.85 ohm. Okay. So such a way that these problems are solved of the resistances in parallel. Look at another one problem we have to see in similar way. Okay. Now next problem is, if resistor having resistances of 20 ohm, 25 ohm and 50 ohms are connected in parallel, what is the effective resistance in the circuit? Okay, same way. Again we have to write all the given resistances, R1 20 ohm, R2 25 ohm and R3 50 ohm. Now look at formula. 1 by Rp is equal to 1 by R1 plus 1 by R2 plus 1 by R3. Okay. So now look at, we have to put all the values of R1, R2 and R3 in the given formula. So 1 by 20 plus 1 by 25 plus 1 by 50. So now look at here. 20, 25 and 50. This is not common denominator. So we have to make it common. Okay. So now we have to find their LCM, least common multiple. If you see 20, 25 and 50. So there are, we see that 100 is their least common multiple. How much? 100. We know 20 into 5, 100, 25 into 4, 100, 50 into 2, 100. So not any number, any less number than 100, which is in common multiple, least common multiple of all these three numbers. Okay. So we have to make denominator 100 of all these three terms. Then we can add them. Okay. So look at 1 by 20. We have to make this 1 by 20 to 100. Okay. This 20 to 100 means we have to multiply this 20 by 5. Then it will become 100. If we multiply this 20 to 5, same number we have to multiply to numerator, plus 1 by 25. 25 to 100 we have to multiply it by 4. So 25 into 4, same number we have to multiply to numerator. So 1 into 4. Okay. Plus 1 by 50. We have to make this 50 to 100. Then we have to multiply this 50 by 2. Similar number we have to multiply to the numerator. So 1 by 2 divided by 100. Okay. So it will be 5 by 100 plus 4 by 100 plus 2 by 100. Now denominator is same. Then we can add this numerators. Okay, so 5 plus 4 9, 9 plus 2 11, so it will be 11 by 100. Okay, so 1 by Rp is equal to 11 by 100. Okay, so look at this is the value of 1 by Rp, but now what we have to find here? We have to find Rp, so we take reciprocal of this term. Okay, so this Rp will be get in the numerator and 1 will become to the denominator, so 100 will go into numerator and 11 come in denominator. So Rp is equal to 100 by 11, and 100 by 11 is 9.11. Okay, so when we are connected these three resistances of 20 ohm, 25 ohm and 50 ohms in a parallel connection, then their equivalent resistor will be 9.11 ohm. Okay, so such a way that we have to solve the problems of resistances in parallel. So here we have to remember only the steps of problem solving, that is the given formula. Then we have to put values of R1, R2 and R3 in this given formulas. Okay, then one important step is we have to add these three terms. So we cannot directly add these three terms because their denominator is not same. If denominator is same, then we can add directly, but here first we have to make their denominator common. Okay, so these three terms we have to find out the least common multiple. Okay, which is the least number which is in common multiple of all these three numbers. So here we will find 100 is the number which is in common multiple of all three numbers. So we have to make this denominator how much? 100. So how can we make this denominator 100? So that will be 20 into 5. Okay, 25 into 4 and 50 into 2. Okay, so it will be 100, it will be 100, it will be 100. So now all the denominators are same. Okay, so we will take one common denominator 100 and we add all these terms of the numerator. So 11 by 100 and 1 by Rp will be 11 by 100, but we have to find resistance in parallel Rp, so it will be equal to 100 by 11. Okay, and it will be 9.11 ohm. Okay, so such a way that we can calculate the problems based on resistances in parallel. In next lecture we will see another different problems. Okay, so up to now you also solve 2-3 problems. Okay, you can take any values of resistors, any 3 values. Simply you have to calculate here their LCM. Okay, take any 3 values and solve another 2 problem. All of you, okay, solve another 2 problem, take any 3 value. Okay, so the next topic we will see in tomorrow's lecture. Thank you.